Welcome to Dozochem. This video covers molarity of ions in solution. If you have an ionic compound and it's dissolved in water, so it's aqueous, the cations and anions, the positive and negative ions, will be completely separated in the solution. So they will no longer be stuck together like they would in the solid. They'll be floating around separately. So here's an example, 0.3 molar CaCl2, and we want to know what's the molarity of each of the individual ions, the calcium ions and the chloride ions in the solution. So to figure that out, you just need to look and see how many of each ion is in the formula. So calcium, there's one. It's not written, but you assume there's a 1 there. So there's one calcium ion. So we multiply the molarity by 1 to get the molarity of the calcium ions. And we know that calcium's in column 2 or group 2, so it's a +2 charge. Now for chloride, on the other hand, there's a 2 here. So we are going to multiply the molarity by 2 to get the molarity of the chloride ions, Cl-. You know that because it's column 17. So it's going to be double the molarity of the calcium ions because there's twice as many chlorides as calciums in the formula. Let's do a couple more examples. 0.15 molar FeNO3 so there's one Fe in the formula. So it's going to be just 1 times the molarity to get the molarity of the iron ions. Now you may be wondering where I got this +3 from, because iron's a transition metal, so you can't just look at the periodic table. You can figure out it's +3 because nitrate is a polyatomic ion with a -1 charge, and if there's 3 nitrates, that's a total of -3. It must mean that the Fe is +3. Now, as far as the nitrate goes, NO3, there's 3 of them. So we're going to multiply the molarity by 3 to get 0.45 molar, and that would be the molarity of this polyatomic ion, NO3 minus nitrate. Next example, 0.2 molar NH4,2CO3. That's called ammonium carbonate. So for the ammonium, there's 2 of them in the formula. So I'm going to multiply the molarity by 2 to get 0.4 molar. And NH4 is known to have a +1 charge. For carbonate, there's just 1 of them in the formula, so we're just going to multiply the molarity by 1. So the molarity of the carbonate, CO3 2-, is 0.2. So that's it for this video. Good luck.